I want to just address two questions that may have occurred to you as you've been watching. One of which is, well, why doesn't this node here have the options to set initial, set always, and so on? The answer is that this node is in fact a digital asset. In other words, it's a container for other nodes. If I double click, we can see that we've got rather a complicated network here, the essence of which is to take data from either the object or from these parameters here and then apply it to the object, and it does that using two different types of node. It uses these motion nodes, and as we can see, the motion nodes have the usual use default, use set initial and so on, and it's set to set always, so it's always bringing in that motion. Alternatively, if we're bringing a data from an object, it brings it in like so, and the active value, that bit of data that I showed you earlier, is set here using an active value node, and it's set always, so it's being set at every frame. You don't usually need to dive inside these nodes to see what's going on, but it can be useful to understand what's happening to this data and how often it's being set. And in this case, both the active value and this position information is being set at every frame. By the way, if you wanted to keyframe the object directly, you could set use object path to 0, and then you could simply keyframe the position and rotation parameters here in the normal way, and those would be used to determine the position and rotation of the object as long as the active value was 0. Let me reset that. The other thing I wanted to comment on is that, of course, we've applied some animation to this box at object level. Why is it that when we have our box falling, the whole sort of context in which the box falls isn't being animated by the animation we've got here? You might expect that if this was stationary, if there was no animation, our box would simply fall to the ground. But if we've got some animation on this, then the box would fall to the ground, but that whole sort of context would be animated because we've got that on the container here. Well, the answer is, if we go in and have a look at our DOP import node, it has a option here, preserve world space positions, and what that is doing is ensuring that no matter what happens up here on our box, the animation simulation is in effect happening in world space, and the animation here is being accounted for so that all we see is what we would expect, which is the box moving along and then falling. So in general, you don't need to worry about that issue. If I turn it off, let's have a look at it, you can see that something really weird happens, which is that the box zooms along and falls rather higher above the plane. It just doesn't make any sense to have that turned off. I've deleted the RBD keyframe active node, and I just want to briefly demonstrate how to achieve a similar effect using just the basic nodes available in the DOPS context, and also introduce a very useful function and some of the way variables are handled in DOPS. So the first thing we need to do is animate our active value so that the RBD simulation doesn't start at once. So we can do that using an active value node. Let's insert one, and we need to keyframe the active value. So at frame 1 we want an active value of 0. Alt left click to keyframe that, and at frame 25 I want a active value of 1, and again Alt left click to keyframe that. Let's have a look at that in the channel editor. I can just drag it in. Now you can see at the moment it has this smooth transition between the value of 0 and the value of 1. That's no good because we want a stepped transition. We want it to change straight away at frame 25. So I need to click on that portion of the curve, and then down here in the bottom right hand corner we can specify the animation curve type, and what we want is constant, and that gives us a step here at frame 25. And let's see what that now looks like. Rewind our simulation, and for some reason the RBD simulation is starting straight away. Well, the reason for that is that the default operation here is set initial, and in fact we need, because we've animated this, to set always. And now we should find that it waits to frame 25 before it starts falling. How could we then add some animation to our box? Well, there are several options for doing this. At the most basic, there's a node called RBD state, and the RBD state is one way of setting directly these position parameters. And if we have a look here, we can see that the data type of position is RBD state, which corresponds to the name of this node. Let's insert that. Now, the RBD state node allows us to set the position, rotation, velocity, and so on directly. It's going to set these fields here, position, velocity, and so on. And we want to set the position. I'm going to set it at every frame, and what I want to do is move the object a little bit along the x-axis at each frame. Now, unlike in SOPs, you can base the values here on the previous value at the last frame, and the way you do that is by using variables. And in general, variables are set up which correspond to the names of the parameters here. So in this case I can access three variables which are going to be $tx, $ty, $tz, which represent the position in x, y, and z at the previous frame. So if I type in here $tx minus 0.1, at every frame I'm going to find that $tx is set to the value of the x position at the previous frame minus 0.1. Let's have a look at that. And now we can see that it keeps moving along and it falls down, but even once it's fallen it continues to move. So ideally I want to stop this RBD state node applying when the active value becomes 1. And I can do that using the activation parameter. And almost all the DOPS nodes have an activation parameter. When activation is 1, then they're evaluated, and when it's 0, they're not evaluated. So what I need to do is set this using a formula. And I'm going to first of all delete the channel information, and I'm going to set it using a formula using a function called DOPOption. And DOPOption is a way to access values inside this tree. And as we can see, it takes a string, which is the name of the DOP network, followed by an object specification, followed by the subdata name, in other words, the name of the container in which we want to find our data, and then finally the field name. So almost always the first two entries in your DOPOption function are two local variables, DOPNet, which names the current DOP network, and DOPObjID. ObjID gives you the object ID of the current object that you're processing. And then we need the subdata name, and in this case it's solver params, and then a slash, and then active value. And then finally we need the name of the bit of data, and that's called active. And we can see that here if we look at active value. The bit of data that contains the active value is called active. So what this should do is have a value of 0 when active value is 0, and then once that active value becomes 1, that will become 1. In fact, we want it to be the opposite. We want this to be enabled when active value is 0, and then disabled when active value is 1. So I need to have 1 minus the value of active here. So we should now find that the cube moves along, and then at frame 25 it suddenly stops and the RBD simulation starts. What happens if we wanted our cube's velocity to continue to propel it onwards instead of just coming to an abrupt halt? Well, there's another node that you can use which automatically calculates the velocity for you. It's very similar to the RBD state node, and indeed we could set the velocity here. We could set it manually. We know that it's minus 0.1 per frame, so it's 0.1 minus 0.1. Now the velocity is in fact per second here rather than per frame, so I need to multiply it times $FPS, which is the frames per second, and that should give us the value of the velocity. And then we should find, if I set this always, we should find that it inherits the velocity. You can get this to happen automatically if you use a motion node instead of RBD state. The two are very similar, and we can see that the motion node automatically calculates the velocity using a formula here. So you can keyframe the position, and the velocity, providing you put this at set always, will be automatically calculated. So let's move now on to a much more complicated example of how to set the position of an object using data from outside your DOPS network. So the purpose of demonstrating these two nodes was to introduce the DOP option function and to introduce the activation parameter here. The easiest way to achieve what we've just done, as we demonstrated earlier, is the RBD keyframe active node. The reason I wanted to demonstrate these nodes is that we're going to use them in the next and more complicated example.